Alright, so in this one we are going to talk about identification of salts. Of course, it includes ions, cations, anions, and obviously some gases sometimes. Alright, so let's begin. Which aqueous reagent liberates ammonia from ammonium nitrate on warming? Now you have to remember that ammonium nitrate is acidic, which means if you add an alkaline solution to it, it will liberate ammonia and not react with that either. So the answer is going to be potassium hydroxide because that is alkaline. 4 test tubes are set up as shown. Alright, what is the effect of adding dilute HCl to each test tube? Now, of course, HCl will react with these salts, but not all of them maybe. And it can produce precipitate with silver, with lead. So we can say that with 2 of these, it's going to form a precipitate, which is silver and lead. So that's going to be W and Y. And then with the rest of them, it will not produce a precipitate. It will be a clear solution. So our answer is going to be B. The results of 2 tests on solution X are shown. Which ion is present in solution X? So let's see what's happening. We add aqueous sodium hydroxide. We know that's a test for cations. It gives us a white precipitate. Now that rules out any transition metals. So this is not going to be our answer. And the precipitate dissolves. Now that rules out calcium because calcium is going to give us an insoluble white precipitate. Alright, now aqueous ammonia, when you add it, white precipitate is made, so it could be zinc or aluminum, but precipitate remains, which rules out zinc because zinc is soluble in both of them. So our answer is going to be A. A student plans 2 experiments. Experiment 1 is to find the concentration of a solution of sodium hydroxide by titration with HCl. That is something we have done in paper 4 as well. Find the rate of reaction between pieces of calcium carbonate and dilute HCl by measuring the volume of gas given off. Now in the first one, there is not going to be a gas given off. So we will need to use an indicator, which means we'll do titration as they've said. And of course, what do you need for that? You need burette, pipette, a beaker, of course. So it could be burette, pipette, which is B or C. Now experiment 2, we want to figure out the rate of reaction. Now rate is useless if you don't measure time. So we will need to know the time, and we are trying to figure out the volume of gas given off. So because of that, our answer is going to be C because it includes a gas syringe and a clock to measure time. A small amount of aqueous copper 2 sulfate is put into a test tube. A few drops of aqueous ammonia are added to the test tube. Then an excess of aqueous ammonia is added to the same test tube. This is a standard procedure. We add a few drops to see if there is a color change, and then we add it in excess to see if it dissolves or not. What are the 2 observations? So we have copper 2 ion. So copper 2 produces a light blue precipitate which dissolves later on, forming a dark blue solution with aqueous ammonia. So yeah, this is going to be our answer. Moving on. After acidification with dilute nitric acid, a colorless solution of X. So it's a colorless solution, which means there is no transition metal ion present. Reacts with aqueous silver nitrate to give a white precipitate. So silver is reacting with it to produce a white precipitate. Now the white color tells me that silver is going to produce silver chloride. If it was yellow, I would have said iodide. So I'm going to go for a soluble chloride because it will react with silver nitrate to produce white silver chloride. So that's going to be sodium chloride. Aluminum chloride is dissolved in water and the resulting solution is divided between 3 test tubes. So we have aluminum chloride, which will give the reagents of 3 tests which could be used to confirm the presence of aluminum chloride. Now you want to know whether it's a chloride and you want to know if it's a aluminum. Alright, so what do we do in this case? We can add sodium hydroxide to 1 and aqueous ammonia to 1 to figure out if it is indeed aluminum. And then for the chloride one, we need to add silver nitrate, and of course it helps if you add a dilute acid to figure out that if there is a carbonate, it can be destroyed. Now you can't add hydrochloric acid because that will produce chloride itself and that will be tested positively by silver. So you can't use hydrochloric acid, but you can use other acids. Usually we use nitric acid because it does not produce a precipitate. So based on that, we need sodium hydroxide, aqueous ammonia, and nitric acid and silver nitrate, which is going to be D. A substance dissolves in water to form a colorless solution. This solution reacts with aqueous silver nitrate in presence of dilute nitric acid to give a yellow precipitate. That yellow color and this silver confirms that I have an iodide. Now, because it's a colorless solution, this also tells me I do not have a transition metal. So based on that, I can say that I have calcium iodide. All right, let's see what the question here is. A solid mixture R contains 2 cations and 1 anion. The table shows the test that a student does on R. Complete the table. Identify any gases that are formed in the test. All right, R is dissolved in water. The solution is divided into 3 portions. A colored solution is formed. The color tells me that transition metal ion is present. All right, that's what I know. So transition metal ion is present. All right, next we obviously add aqueous ammonia, and that is in small quantity, giving us chromium 3 or iron 2. So that means we are getting a green precipitate. You can say just PPT in the exam and that will be fine. An excess of aqueous ammonia is added. So chromium 3 and iron 2, we know they are insoluble. So precipitate insoluble is something we can mention to know that it is still either one of them. We are not sure which one. Then they're adding aqueous sodium hydroxide. So again, that gives us the green precipitate. And we know that in sodium hydroxide, chromium 3 dissolves, but iron 2 does not. So because of that, we can say that precipitate dissolves. Now, don't say that chromium 3 precipitate dissolves because we don't know the formula of chromium 3 hydroxide at the moment. And we also are not sure before we see the precipitate dissolving whether it dissolves or not. Okay, so precipitate dissolves is what our observation is going to be. Moving on, the mixture from C2 is warmed and the gas formed is tested with red litmus paper. The gas turns it blue. This is going to be an ammonia gas, and that confirms that I have ammonium ion. So ammonium ion, and you can mention that ammonia gas given off if you want. It's a 2 mark question, so I would suggest that you mention that. All right, next we have sulfate. Now for the sulfate, what we do is we add barium nitrate because barium is an ion that forms sulfate precipitate. But we also need to make sure that we are adding some nitric acid to make sure there is no carbonate present, because that might also produce its own set of precipitate. So add dilute nitric acid, or you can write the formula of that thing, and barium nitrate solution. If you're not sure about the formula, which you should be by the way, but you can still name it instead of writing the formula. And we will get a white precipitate, and that is how we know that we have sulfate ion. So you see that it is basically the table that they have in the syllabus that they're testing us on. And there is the test, observation, and the identification, 3 parts there. And we should be able to do any one of them. Now this is another question. What's happening here is the student is provided with 3 unlabeled bottles, which each contain a solution. The student knows the bottles contain these 3 things, but the student is provided with these 3 things and no other chemicals. We want to know which one is which. Now remember that you can only give a positive test. You cannot give a negative test that, all right, do this, if this doesn't happen, it might be that. No, do this and this must happen. That is how you know what the thing is. For example, with HCl, we know that if I add silver nitrate, it will give me white precipitate. With aluminum sulfate, I know that ammonia will give me white precipitate that does not dissolve, and sulfate will react with barium, but I don't have barium here. Similarly, with zinc sulfate, I know that zinc will react with aqueous ammonia to give white precipitate that dissolves in excess. So based on that, I can figure out which one is which ion. So alright, so let's start that. Let's say we add dilute nitric acid, followed by or and aqueous silver nitrate. If a white precipitate is formed, it is aqueous HCl. Alright, so that tells me that white precipitate is being formed. Next, add few drops. Now it's important to mention few drops. Few drops of aqueous ammonia. If a white precipitate forms, because with HCl it will not create a white precipitate, forms, add it in excess. If PPT dissolves, it is aqueous zinc sulfate. If PPT does not dissolve, it is aqueous aluminum sulfate. And there you go, we have tested all of it, and now we know how to not only design experiment but also to test, observe and identify any cations and anions.